Welcome, everyone. My name is Casey Wang. I am a co-PI on the Fabric project. Thank you all for joining us today for the 12th installment in our Master Fabric Tips and Tricks webinar series led by Kamal Tareja. Next slide, please. Before we begin, I'd like to first share a few housekeeping items. The webinar will include a live question and answer session following the presentation. Please note that the chat feature of Zoom has been disabled. Instead, if at any point you want to ask a question, please go ahead and type it into the Q&A box at the bottom of your screen, and we will answer it during the Q&A session. Last, this webinar is being recorded, and it will be shared with all the registrants. Next slide, please. Today, we're joined by our presenter, Kamal Tareja. Kamal is the Senior Research Software Engineer at Renzi Fabric, where her work focuses on building programmable cyber infrastructure that enables large-scale, reproducible experimentation across edge, network, and cloud environments. She leads the development of core platform capabilities, supporting advanced networking services, heterogeneous accelerators, distributed storage, and experiment orchestration. Her research interests include distributed intelligence, decentralized and multi-agent systems, programmable networks, and AI-driven scientific workflows. Prior to her research career, Kamal gained extensive corporate experience architecting and implementing large-scale applications in the communications industry. Her work emphasizes bridging industry-grade system design with experimental research to support disruptive real-world systems experimentation. I will now pass on to Kamal to start the presentation.
Thank you, Casey. Good afternoon, everyone. Sorry. Good afternoon, everyone. Okay. So today's webinar is about distributed storage service, and I will begin by talking about why we thought about building this service and how it helps the users. So let's begin by looking at the core challenge that motivated the development of this storage service. Most cloud and testbed environments rely heavily on ephemeral storage. So in practice, this means that you have storage attached to your VM or a compute node, and the lifetime for that storage is while your VM or the compute node is up and running. And when, in Fabric's case, a slice is terminated or rebuilt, the storage associated with your VM goes away. So for short experiments, this might be acceptable, but for many modern research workloads, this becomes a significant limitation. We do have a way for you to persist your data today with a solution called persistent storage, but that is very limited, and it is limited to specific sites, specific locations within Fabric. So if you requested a persistent volume at, for example, one of our sites called Starlight, your data would just persist there. And if you wanted to use it anywhere else, you would have to still manually transfer the data set. So in order to improve on that, we thought of implementing this distributed storage service. Uh, the idea behind this is that increasingly the workloads which are distributed across multiple nodes or even multiple sites. So the experiments you are running today are not limited to a specific site. And with Fabric's imprint, you can run them at different locations. For example, if you were running an experiment involving AI or machine learning training pipelines, it would involve multiple compute nodes accessing the same data set simultaneously. So without shared storage, users would have to manually copy the data between the nodes, which is inefficient and error prone. And in order for in typical Fabric experiments span multiple geographic locations, and moving large data sets across sites takes a lot of time and it's slow. So that's when this idea of Fabric storage service came into being. The intent being that you store your data once and can reuse it often instead of repeatedly rebuilding your environments and data sets for every experiment. We want to give users the power in which they can create their persistent data sets, and that can be used across multiple runs or multiple workflows or multiple execution of their experiments um, on different locations within Fabric. So the vision behind Fabric storage service is quite straightforward. We want every Fabric user to have access to persistent and shareable storage independent of the lifetime of any particular experiment. This means like if you create a dataset today, it should remain available even if your compute resources are destroyed or recreated tomorrow. At the same time, the storage service should be accessible across multiple Fabric sites, allowing experiments running in different locations to access the same data. This is a difference from our existing solution, which is the persistent storage volumes you are currently using. In order to support this, the system we have designed is around three key principles. High availability, that means data is replicated across the storage nodes, and the system includes self-healing mechanisms that automatically recover from failure. I'll talk a little bit more about it in the subsequent slides, but basically our storage nodes keep three copies of your data. So even if in case of one of the sites where the storage node is located goes down, your data is not lost and is still available. Um, uh, in order for us for users to use this service very easily, we are exposing existing standard interfaces rather than uh, using any new protocols. We expose like well-known interfaces such as S3 object storage and POSIX compatible file systems. So this would allow users to work with familiar tools and existing software stacks. So for example, in this case, you could just download the S3 SDK and directly start using S3 buckets if that is what you requested to use, or mount the file system on your VMs and start using it like a regular file system. Another idea behind this is dynamic scalability. As Fabric grows, the storage capacity can grow with it. We can add more nodes to the cluster without disrupting existing users. So to begin with, our storage cluster has a set of capacity, but as people start using it more, we would be able to extend it as needed. So with all these things in place, uh, we are able to build a storage platform that behaves less like temporary experiment storage, but more like a persistent research data infrastructure. So to understand like how this storage service operates, I'm going to this you may have seen this slide multiple times, but this slide just shows how Fabric, what is the footprint of Fabric and how Fabric infrastructure looks like. So Fabric is a geographically distributed research testbed with sites which are spread across United States and internationally. These sites are interconnected through high performance research networks. So in the diagram, if you see the network links depicted as orange links are 1.2 terabit links, and then the blue links are 100 Gbps links. So the distributed infrastructure Fabric offers provides a unique opportunity for experimentation, but it also introduces challenges for data management. If the compute resources are distributed across sites, we need the storage that can support both local performance and global accessibility. So the storage service leverages this existing Fabric backbone to create distributed storage regions. And this allows data to be placed close to where your experiments are running while still remaining accessible from other regions when necessary. So in other words, the storage architecture is taking advantage of Fabric's network connectivity to enable multi-site data access. Now let's look more closely at the architecture of the storage system. Fabric storage service is built using distributed architecture deployed across multiple regions. So as you can see that we have segregated the entire testbed into four regions. Within each region, we have deployed a Ceph storage cluster, which provides both object storage and file system capabilities. Users can interact with these storage clusters as clients from their slices or experiments. And this offers multiple benefits. It allows storage to be geographically distributed. So, for example, if you had an experiment which was running in US East region, then you could use the volume or you could use the storage in that region and have your data easily accessible. I would show which sites belong to each region in the next slide, but this gives you an idea. Like if your experiment is running in a specific region, it might make sense to put your data in that region. So workloads can access storage resources within their region, reducing latency and improving throughput. You could still access data from, if your experiment was running in East region, you could still access data from Asia region as well. If your data was stored there, it would just have a little bit more latency as compared to if it was local. So this distributed design aligns well with the way many modern scientific workflows operate, distributed across multiple nodes and often across multiple locations. So currently we have there are four regions defined for the storage service. Includes like West region, East region, Europe, and Asia. You can see we have picked up different sites under each region and provides access to storage services within that geographic area. Within each region, users can access both S3 compatible object storage and Ceph FS file system storage. This structure helps balance several important factors. It improves performance by allowing data to be remain closer to your compute resources. For example, if you were running an experiment in the West region, you might want to put your data in the West cluster and run your experiments on the sites like Los Angeles, UCSD, or Salt Lake City. It is still possible you could have your data hosted on the Asia cluster, which is Seattle, Hawaii, and Tokyo. Um, the only difference would be the latency may be slightly more as compared to if it was local within the West region. In fact, that also gives you an opportunity to see how your system behaves with different kind of latency for the data. So underneath the Fabric storage service is the Ceph, which serves as the core storage engine. Ceph is a widely used open source distributed storage platform used in many cloud and HPC environments. Ceph provides several key components, like there are monitor nodes that maintain the cluster state, ensure consistency across the system. We also have object storage daemons that manage the actual storage of data across disks and nodes. And then there are gateway services which expose the object storage through S3 compatible APIs. Ceph also provides Ceph FS, which allows users to mount a distributed file system using a standard POSIX interface. So by using Ceph, the storage service benefits from built-in features like data replication, self-healing, and scalable architecture. So in this case, we have configured Ceph in such a way that we retain 3 copies of your data, and there are multiple OSD nodes across each cluster. So if one of the node went down, your data would still be maintained. We have also integrated Ceph with it and its authentication mechanisms with Fabric tokens. So you don't need anything extra to use these services. Your Fabric tokens would just work out of the box. While Ceph is powerful, managing a Ceph cluster directly can be a bit complex. It may not be as easy as we may think. So to simplify that process, we built a Ceph Manager web service. So this service acts like an abstraction layer between the users and the underlying storage infrastructure. Um, you would not be directly aware of this service, or you may not see this. This is maybe running behind the scenes, but Fablib, the Fabric API, behind the scenes would talk to this service to find details about the volume you have or the S3 buckets you have, and or what are your credentials. Do you have permissions to use that storage or not? What is your quota? And can you request permissions from, let's say, if you created a volume and you wanted everybody in your project to have access to it? We are using this web service to control all that. Uh, and this service has integrated it with Fabric tokens, so you don't have to do anything extra. Your existing Fabric tokens would be used to allow you to access these storage resources. So that means the users can interact with storage without needing any deep knowledge of underlying Ceph architecture. So from an experimenter's perspective, interacting with the storage service is designed to be very simple and flexible. We'll learn that about more about that in the tutorial section. Users can provision persistent storage allocations with quotas assigned to their projects or individual accounts. So you can request an individual volume, which could be X amount of size, or you could request project volumes and share it with everybody in your project. You could also do something similar for not only volumes, but also do S3 object storage. So you can request S3 buckets and use the S3 clients or SDKs to access those buckets. For more advanced use cases, you can, if at all you need to, you can deploy your own Ceph cluster. We are sharing an artifact on that too. So you can deploy your own Ceph cluster and use that to manage storage for your experiment or your project if needed. Security and access control are integrated with Fabric tokens to ensure that the storage access is properly authenticated and authorized. So, for example, if you requested a private volume, like which is like your individual volume, only you would have access to it, no one else can access it. And if you requested a project volume, and everybody within your project would be able to access that volume. Or for that matter, both the buckets, S3 buckets as well. Persistent storage enables many important research scenarios. This slide talks about some of them. For example, AI and machine learning. So often experimenters need shared access to large training data sets, and having to download that data set multiple times or being restricted to a specific location could be a problem. So persistent storage allows multiple compute nodes to access these data sets simultaneously without the need for data transfers. Another example could be the data science workflows. So storage allows data sets to be reused across multiple experiments without repeatedly transferring the data. So again, the idea is you just copy it once and use it again and again. Even for HPC pipelines, you could have persistent storage that ensures the outputs and the intermediate data remain available even after the compute jobs finish. So oftentimes when we are running an experiment or working for tests for a paper, you could save all your outputs and data on this shared storage. And even if your slice expired or you forgot to extend it or you forgot to download it locally, your data would still persist. You can come back and create a new slice and still have your experimental results available for you. And for uh, us being the test bed operations, we can share images, configuration files, that can be used across multiple slices, reducing the setup time. So overall, this storage service is transforms Fabric from a purely compute-focused testbed into more data-enabled research platform. I mean, I should not say compute-focused, but compute and network-focused into more data-enabled research platform. At this point, I will show you how how you can use this storage within your experiments. Let's go back to the Artif Fabric portal. I'm on the Fabric portal. I'm going to log in as myself. If you log in and go to experiments, there is Artifact Manager. And if you see, we have an artifact called distributed storage notebooks. This is the artifact I'm going to use to show how you can use it. But before I do that, I also want to show you how would the storage be accessible, what kind of credentials you would be using, even though you don't need to use them directly, but they are used behind the scenes. So if you go to Manage Tokens here, it opens Fabric's Credential Manager. As you can see, there are multiple tabs. This is the traditional tokens. These are the traditional Fabric tokens. We added a tab here called Storage Token, and it takes because it's now right now querying the Ceph service. It it figures out there are multiple clusters. As I said, there are 4 clusters, so you can see all 4 clusters. And it seems I don't have any credentials for Asia cluster. Let's see if I have any credentials for the other cluster. So as you can see, I have a volume for on the Asia cluster, and these are the credentials I would need in order to use that. So you could download these credentials if needed from here. But let's not get into that right now. I will show you how to use this. I just wanted to give you a context on how you might see these credentials on the credential manager. In order for our people to use this, what we did was for every user who has been active for last 30 days on Fabric, we created volumes for them of 1 gigabit size and gave them permission to use that, like enabled them to use the storage out of the box. So you should be, if you follow along with me on this tutorial, you should be able to run this without any problems. And if you don't see access to it, just let us know at the end of the tutorial by posting on our forum, and we could add you there. So if you log into Jupyter Hub, okay, sorry, I should have mentioned one more thing. If you log into Jupyter Hub, maybe give me 1 second. I'm sorry. I realized that I had logged in earlier, so it is not showing that option. Yeah. So if when you open the Jupyter Hub, you see these 4 options. I would suggest using one of the bottom 2 options because that is where this service changes have been rolled out. So I'm going to use the bottommost option, which is Beyond Bleeding Edge. So either the Bleeding Edge or Beyond Bleeding Edge should be good to use. It just takes a couple of minutes to bring the container up. If you log in there, you can either go to Jupyter Examples main or Jupyter Examples 1.9.0. Either one is okay. And there is a Start Here notebook. Within the Start Here notebook, there is this Explore Fabric Artifacts notebook. Let's use that. This notebook shows all the artifacts which are available on Fabric Artifact Manager. And since I'm looking for only storage artifacts, so I can search based on that. And there are two storage artifacts. One is the persistent storage. This is the existing way of using a persistent volumes, which are restricted to specific sites. But our storage service artifact is the top artifact. So you can download that. It says it has been downloaded. I just need to go out in my home directory to see that. If you see, it's here. And it has a bunch of notebooks in it. One is the Ceph FS storage, and then some of the benchmarking notebooks. Let's go in the Ceph FS storage notebook directory and see what we have. I'm going to show a basic notebook, as in how you can use these volumes or Ceph storage within your slice. This notebook walks you through how to use that. Let's just run with it, and then I will talk about how it, because it takes a little bit of time for the slides to come up. While we are doing that, while this is coming up, what it does is basically it tries to get two random sites on Fabric, and it's going to create two VMs. Uh, in this case, one on Massachusetts and one on GA. And if you notice here, in when I requested a slice, I passed this flag called storage equal to true. This is the flag which is controlling whether my storage volumes, in this case, should be mounted on the VMs or not. So that's all. If at all you want to use these storage volumes, that's all you need to do. Just mount these, pass this flag, and then that volume would be attached to your VM, and you would be able to save content there and see. While this VM is coming up, let me also run the rest of the parts of this so we can see that. So once the slice is up, we would be able to see whether what this next step does is basically checks whether my volumes have been mounted or not. As part of this, when you pass this storage equal to true flag, what we have done is we are adding a separate Fabnet v4 network to your VMs and use that network for any of the storage operations. So that way, if your experiment had other networks, we would not impact anything on your experiment networks. It would be a separate network which would allow these VMs to access the Ceph storage cluster we have running on Fabric. The Ceph storage cluster is also using Fabnet v4, which is Fabric's internet. That's how we are able to talk to the Ceph cluster by connecting your VM to Fabric internet, which is Fabnet v4 in this case. It takes about like 300 seconds or 5 minutes for the slice to come up while we are waiting. Let me talk. In the meanwhile, I can also show you while this is working. I also created another notebook which shows how the performance of the Ceph storage. I'll come back to this. I can also show you, if you go to the storage notebooks, there is this Ceph FS benchmarking directory. There is a notebook there called Ceph FS benchmarking. I already created a slice in order to save time, because it takes about 5 minutes for the slice to come up. So I didn't want to wait. So as you can see, I have a slice up. I have three VMs in this slice. In this case, one on EduKY, one on GPN, and one at Utah. And all of these slices I created with storage enabled. So my Ceph volume is mounted. I also have a 1 GB Ceph volume, which let's see if I run this command, df-h, and see, I can verify that my volume is mounted on all three of them, and it is the same volume. Let me open a terminal to one of the VMs just to show you. I am on the EduKY, and if you see, I can see the volume there. And if I I have a volume on Asia cluster. That's why it's showing me there. And this is the mount path you can see. Uh, let's go back here. I have in this notebook, what I'm doing is I'm trying to write to this volume with using either one with Python, another with rsync, DD, and PV to see how does it behave when I am writing to this volume, which is in Asia cluster. And remember, let me go back to this and show you. Remember, Asia cluster is on Seattle, Hawaii, and Tokyo, and all these are far away from that, like HKY, GPN, and Utah are far away from that. But I'm still able to write to that volume. Let me let this run. It will write, and then it'll show the comparison of what is the write speed. So while this is running, let's go back and check our basic slice if it is up and running. It seems like it's coming up. Maybe close. Yeah. It looks like both the VMs are up, the networks are up. I think it should be done soon. And since we passed storage equal to true in this case, in order for storage to be mounted on the VMs, as part of the slice, it'll do some postboard config, and you would see some traces which indicate that Ceph Ceph was being set up on those VMs. In this example, I've used Rocky VMs, which is Rocky 9, but this works on Ubuntu as well. All the supported images we have. See, this is what I was talking about, that it tries to configure Ceph FS on your VMs. It takes a little bit of time because it's trying to install Ceph software. Like it needs some of the Ceph software in order for Ceph volumes to be mounted. So there are packages called Ceph Common and Ceph Fuse that need to be installed. So that's why it takes a couple seconds for it to be up and running. And if you want to look at what packages it installed, you can always check Fablib logs, and that'll give you an idea of that. While we're waiting, in the meanwhile, I can go back to the benchmarking notebook and show you what that is doing. So in this case, it is for it try from the EduKWI client, the code is trying to write a 250 a file which is 250 meg, and then using three different methods. Like it tried with Python first, and this is the data write rated it saw, and with rsync, it's a little slower. But notice that EduKY is far away from the Asia cluster, and it's still getting a pretty good speed of 187 megabits per second, or with rsync 132. It's a little bit slower with DD or PV, but not bad. So it does that for it would do that. It would run this test for all three locations: EduKY, GPN, and then there was one more VM here. I forgot for Utah. So it just completed it for EduKY, but you would see in a little bit how it goes for for GPN. So this is a good example of showing even though the my volume was on an Asia cluster, I can still access it from from VMs which are far away from Asia cluster. But if I really wanted um, the the data to be read faster, I would probably want a volume which is closer to my experiment, in this case, closer to probably HKY or Utah or GPN. That way, the data is accessible almost as it is local. While it's running the test for on Utah client, let's see how our basic notebook is going through. In this case, if you see, it says the VMs are up and have been configured, and my slice is up. It took about 586 seconds, and now in this step, it is checking if the volumes were mounted. In this case, yeah. And if you see I have volumes on the Asia cluster, that's what it is showing. And in this case, in this step, I had two VMs. One of the VM was at JTech, other was at Massachusetts. So I'm writing a file from the VM on JTech, and I can verify that read the output or read that file from the node 2, which is at Massachusetts, and then uh, write it back, vice versa. So that is what this slice does. If you follow this notebook and see how easy it is to use the storage, all it took is passing this one flag. In this case, if you pass this flag as true, all the VMs in your slice would have the volume mounted. But if you want a more granular control, as in you just want your volume to be mounted on specific VMs, that is possible too. Okay, sorry, I think I was running this before, so maybe I already have a slice with this name, so I'm going to change the name of the slice. So it doesn't conflict. So in this case, instead of enabling storage at the slice level, what I'm doing is I'm choosing specific nodes where the storage should be enabled. So in this case, there is only one node where I have passed in this flag called storage true. So the storage volume would only be mounted on that node. And if you were, and the other node, we did not pass the storage flag. So that would not have the volume mounted. Again, this would take like about 5 minutes for the slice to come up, and then we can verify it. While we are waiting for that, I can go back and show you how the benchmarking notebook went through. In this case, now you can see that um, right, all three clients completed, and these are the rates they observed. So this is from EduKY client, even though my volume is on Asia cluster. So Python, rsync, and DD and PV, different ways of writing files to these mounted volumes. And all of them were done. So let's see. And this cell generates a plot to compare the performance across them. So let me show you how it. So uh, if you see the throughput in this case across different sites and across different kinds of mechanisms, DD seems to be seems to be performing the worst. Python seems to be higher, but it could be because it's using the RAM and caching the output in in the RAM in the memory and then writing it. So that's why it's faster. rsync is definitely better than PV and DD. And then this just shows a distribution of the throughput across different ways of writing to these volumes. And you can see how it varies for each site. And if you were, in this case, this is if you were writing to Ceph volumes and how it behaves Now we're trying to compare if you were writing directly to your local disk. In the VMs I created, I requested a local disk, which was 50 gig. Go back up a little bit. Oh, okay. I have a disk for 500 gig. That's why. Um, but you can see compare the throughput between the writes between when you're writing to Ceph-FS or you're writing to. So if we see for educate client, we see writes, but the highest writes is 200 Mbps. But if you compare it against local, obviously it's faster. It's 1.7 gigabits per second. So definitely you see a huge difference. Yep. This is the comparison chart between for different kinds of tools, how it compares between um, the local and the Ceph, like how much is local faster versus the Ceph. But the idea is that even though it may be not as fast as local, but it allows you to have data, which allows you to save data once and access it anywhere across Fabric. Uh, you're not restricted by a site. So you don't, if you request, for example, in the current setup, if you requested a persistent volume at Starlight, you were always restricted and you could only have one VM on Starlight mounting that volume. But with the Fabric storage service, you could have multiple VMs mounting the same volume from different locations and still have access to that data and can easily rerun your experiments by changing different locations, by changing um, different results, can save all those results in that volume and always have access to it, even if you forgot to extend your slice or if you deleted your slice, so your data is never lost. Again, in this case, we are comparing the throughput between Ceph versus local, and obviously local is much faster comparing to Ceph, but that is expected. This is about the benchmarking, and then let's come back here to this notebook wherein I had node level control over where the volumes should be mounted. So in this case, both my slice is up. I only requested on volume to be mounted on the storage node, which in this case is the node on Clemson. Let me let me go here. SSH to the VM. If I do DF, you can see my volume is mounted. Uh, and if I can create any file, and if I delete my slice, that file would still exist. I can write to my file. I'm just using a dd command to show how and write about 256 meg here and show you what kind of write rate you would observe. So this was a very small file, but I have only 1 gig. So that's why I didn't want to write a bigger file. But you get the idea. I am on a Clemson node, and I'm getting about 61 Mbps write rate for a small file. I I think this is what this also does. On the This is the node where I requested storage. I went to the node on Clemson where I requested the Ceph volume to be mounted. But if I look at the other node, which is only compute only, in which case I did not request the Ceph volume to be mounted. I don't have the volume there. So you have complete control of where you want those volumes to be accessible. If you want them to be accessible across all your VMs in your slice, you can do that by controlling a flag at the slice level. If you want to control it per VM, you can do that too. And each of these VMs, when they have access to our storage service, they create a separate network on Fabnet in order to talk to the Ceph storage service, and without so that would not interrupt with any of your experiment data or experiment networks. So this is completely separate, and without interrupting your experiment, you should have access to a shared storage which is accessible anywhere. So yeah, in all these examples I showed, I have a volume which is in the Asia region, which is sitting on any of these nodes here, but I created three slices, one on G, and I could access it from anywhere, from GPN, Clemson, and in the previous slice was from Massachusetts, GA and then this one is also different, HKY, GPN, and UDA. You can, if you followed along with me and if you run into any problems, please let me know. If you didn't, all this artifact is available as an artifact on Fabric. You can download it. You should be able to try it easily. If you run into problems, please reach out to us, and we'll help you with that. Let me go back here. So that's all I have. Like, just to conclude the talk, um, the Fabric storage service delivers persistent distributed storage to all users. We are using Ceph to power it for reliability and scalability. It moves Fabric towards a richer ecosystem supporting AI, data science, and workflow communities. Our next step is broader adoption. So we welcome feedback, dataset contributions, and user stories. So we also welcome any issues you may run into, or we'll be happy to help you address them. And we rolled it out for about close to 400 users who have been active in last 30 days. So you should by default have access to a 1 gigabit volume for you. If you didn't get added as part of that, just reach out to us and we will be happy to enable it for you. Thank you.
All right, thank you, Kamal. So now we will move right into the Q&A session. We will begin with some questions submitted during the presentation, and Kamal will stop screen share, and she will have her camera on to answer your questions. So first question, how Fabric Data Platform is different from AWS?
In order for you to use AWS platform, you do need credits, and you can use it within Fabric too. But not only credits, you do not have control of where that data resides. Like you are giving that data out to AWS, so it's in the cloud. But within Fabric, your data is secure. You as in Fabric user have access to it. We don't do anything with your data. You can still use the similar AWS APIs like S3 SDK if you want to use that, or if you want to use Ceph volumes, you can use that too. And since the data, if you're running experiments within Fabric and running your data is within Fabric, it'll give you a much better throughput as compared to if you were running it on AWS.
Thank you. Second question. Can we check our storage and see what's in it without creating a slice?
No, not right now. You have to create a slice to check what's in it.
All right. Uh, Third question, why was Ceph and S3 chosen instead of other storage options? For example, SFTP, which is mounted with rclone, NFS, which is natively supported in the kernel, and iSCSI allow customizing file system.
Okay. We're running this storage service is actually as a slice within Fabric. In order for us to support NFS or other things you are mentioning, it would require us to create a Ceph storage cluster outside of Fabric. And we wanted to explore how we could use existing Fabric resources and not acquire additional resources and run this as Fabric service. And the idea is that even users can build these some similar services and run them within Fabric as a slice and provide them if those services are they think that they are have broader use, they could share them with other Fabric users. In addition to that, Ceph has this self-healing capability wherein um, if you keep multiple copies of your data and you can divide the storage into multiple clusters and regions so that way even if one of your node in your cluster died, we still retain the data, so self-healing helps a lot. And the PostX file system and S3 interfaces are well known and people already use them a lot. So that's why we thought that if we don't have to reinvent the wheel and use the same interfaces people have been using.
All right. So we have a question here. Could you please explain again how I can request storage? It looks like I don't have access and I'm getting an error when trying to create slices.
Okay, if you go to on the portal, if you go to login and if you go to experiments, and then under experiments, you would see your projects. Select any project you are part of. On top, you would see a button called request storage. If you it opens up a form. On that form, there is a one of the selections is distributed storage service. So if you click on that and fill up that form, we'll be able to help you with that.
All right. Next question. How does costing work in Fabric? I guess this means that is there cost associated with the distributed storage service?
No, there is no cost associated with distributed storage service. Um, if you are part of a Fabric and you are part of an active project in Fabric, you can request storage volumes and or S3 buckets, and we'd be happy to provide you access with that, and you can use them for your experiments.
Yeah, and then I think emphasis is the storage is provided to assist with experimentation, so you're not using that for your regular storage needs within Fabric.
Yes, thank you.
Um, so next question, can you speak to the benefits of integrating your own Ceph cluster into Fabric, especially in the case where your site is not part of the Fabric backbone?
We currently do not have support for that. Uh, in order for you to enable that, you would have to provide connect your Fabric Ceph or your Ceph cluster into Fabric, um, just like you would connect your campus cluster with Fabric. We have this capability called facility ports with which you can do that. And there, you could request office hours and talk to our network team. They could help you in connecting your campus cluster with Fabric, and that way we could integrate your Ceph cluster in Fabric. But right now, this is within Fabric.
Next question. What replication factor do you use, and is it configurable per pool or sub-volume?
Right now, we are using a replication factor of 3. Um, we haven't kept it configurable for users, but we do control it. If you created your own Ceph cluster as a slice yourself using the artifact we share, you have complete control of that Ceph cluster, and you can tweak it there.
Next question. I have noticed the FabNet v4 native is set as the route for 10.128.0.0/10 subnet. So the entire FabNet v4 subnet. This could disturb experiment traffic. Maybe this should be changed to route only the IP addresses for the Ceph servers.
I could take a look at that, but the intent is that even if you have the route set up this way, it uh, it shouldn't impact your experiment network. We could, if you'd like, we could tailor it to be only specific to the Ceph nodes, but we have tested this with our setup. And whenever we want our slices to be connected across within Fabric, we are using this entire subnet. There is traffic shaping behind the scenes, which is not controlled by users because right, this is using all shared NICs. So if you were using dedicated NICs, this would not impact yours. We do have traffic shaping inbuilt on the shared NICs, which is not controlled by users as of today. But if we do see that we just rolled the service out, we haven't seen much usage with it. But if we see that it is impacting experimenters' network, we would tailor it to those needs.
Thank you. The next question, can clients outside Fabric access the S3 Ceph FS endpoints, or is it FabNet v4 only?
Right now, it is Fabnet v4 only. Um, if you come to NIT, we are showcasing other capabilities there, wherein within Fabric, using SSH tunnels, you should still be able to use it. But it is right now within Fabric. We haven't exposed it on public network using Fabnet v4 ext.
Right. Next question, what's the network throughput between regions? Does Ceph replication ever saturate the links?
So far, we haven't seen that, but we are closely monitoring it and plan to tweak the network shaping behind the scenes to not impact experiment networks.
One more question. How do users get started? Do they need to deploy their own client slice, or is it automatic?
All you need to do is when you're creating your slice, you just specify that flag which I showed in the notebooks, storage equals to true. And if you can do that at the slice level or at the VM level, and everything else is behind the scenes. You don't need to do anything manually. You do have to request access to the storage. So if you were not given the access as part of the last 30 like active users from last 30 days, please go to portal and request storage, and we would be able to help you, uh, or create a post on forum, and we'll respond to your query there.
Now, can I mount Ceph FS from an existing slice without using Ceph client's notebook?
Yes, that was not part of the artifact I shared, but there is a there is a way that you could do that, and we could provide instructions on that.
Next question, what are the per user project storage quotas and who sets them?
Uh, This is completely based on what you request. It would be reviewed by the Fabric security team, and based on whenever you request storage, we ask you describe your use case, and we just want to ensure that you are using the storage for your Fabric experiments, not something else. And the security team approves that request and grants that quota, and that's who controls this.
And finally, can I use this for large AI ML data sets with PyTorch TensorFlow data loaders?
Yes, you absolutely can. If you're using the POSIX file system, it is exactly like any other file system. So you can directly connect it with. I'm so sorry. I'm so sorry.
That's all right.
You can connect it with you can connect the POSIX file system with directly any of the AI/ML tools. It should work out of the box. You don't need to do anything extra for
All
it.
right. Well, this is super popular today with the Q&A. That's the last question. So again, I'd like to thank our presenter, Kamal. And now, finally, in addition to the presenter, we'll also like to acknowledge the behind the scenes team listed here on the next slide who worked diligently to bring this webinar to production, particularly myself as Casey Wang and Chelsea Davis as our project manager. Next slide, please. Thank you to the audience for your participation in today's webinar. And In addition to the recording of the webinar, we will also email everyone who has registered with a list of resources. The slide deck will be shared and along with the Connect with Us form. We hope you will reach out to us at Fabric Team for any questions or support. And next slide, our webinar next month will be April 21st at 3 p.m. Eastern Time. It's the Stitching Together Innovation with Fabric Users series. That webinar will be focused on new users, and we would appreciate it if you could forward it to anyone who might find it interested. As a final reminder, please submit your Fabric matrix if you are a Fabric user, and make sure your project description in the portal is up to date because we do use that information for outreach and we do promote that on our website. Thank you again and have a wonderful day.